Welcome to the Motor Resistance and Capacitance Measurement module. Today we'll explore the intricacies of a capacitive start single-phase motor. We'll measure the resistance of its windings, the capacitance of its starting capacitor, and delve into some basic motor operation principles. To start our lesson, let's begin by measuring the resistance of the windings. We can do it by accessing the winding ends in the terminal box on the motor. Can you spot it now? Now that we have access to the winding ends, let's prepare the multimeter for the measurements. Set the multimeter to the resistance ohms mode. Now connect the test leads. Black test lead into the black common input jack, red test lead into the red input jack labeled with the ohm symbol above it. We'll begin by measuring the starting winding resistance. Connect the probes to the highlighted winding ends inside the terminal box of the motor. Observe the reading. This value represents the resistance of the starting motor windings. The measured value is recorded in the pop-up widget. You can compare it to the nominal value provided by the manufacturer. A significant deviation from the nominal value may indicate a fault. Have you observed the reading? What does the measured value indicate? Let's complete a short quiz. Now, to measure the running winding resistance, reconnect the probes to the highlighted winding ends. Observe the reading carefully. This value represents the resistance of the running winding in the motor. Like before, you can compare it to the nominal value provided by the manufacturer. Have you observed the reading? What does the measured value indicate? Select the right option. What else can we measure with this same function? That's right, the resistance from the winding to the motor casing. This will help us ensure there's no unwanted connection between them. Let's now measure the resistance between the all winding ends and the casing, or in our case, a ground terminal. Connect the probes to the highlighted points. Have you observed all readings? A high resistance value here is a good sign. It means there's no short between the winding and the casing. Now let's turn our attention to the starting capacitor. This component provides the necessary phase shift for starting torque. It may degrade over time and can be one of the reasons why the motor won't work. To check the condition of the capacitor, we'll measure its capacitance. But first, can you spot the capacitor on the motor? Great. Now let's get back to our multimeter. To set your multimeter to the capacitance mode, select the resistance mode and press the yellow button to activate the secondary function. On the display, you will notice that the measurement units will change from ohms to farads. Now connect the test probes to the capacitor terminals. Observe the reading. The value you see on the display represents the capacitance of this component. It's essential to compare this nominal value to the measured capacitance value. Let's identify the nominal value of this capacitor printed on the surface. Let's have a look. Great. Now we can compare both values. If the measured capacitance significantly differs from the rated capacitance printed on the capacitor's surface, it might indicate a fault with the capacitor. Our short journey into a capacitive start single-phase motor ends here, so let's check what we've learned today. Welcome to the troubleshooting lab. We've set up the same circuit configuration you've been working with, but there's a problem this time. The motor won't start, and we need your expertise to figure out what's wrong. Based on what you've learned so far, your mission is to identify any faults in this setup. Remember, understanding the readings and comparing them to expected values is the key to successful troubleshooting. To start, set your multimeter to the desired function, just like you've practiced. Let's get to the bottom of this issue and put your skills to the test. Great job! Regularly measuring and understanding these values is crucial in maintaining motor health and ensuring efficient operation. You've now gained valuable insights into motor winding resistance, capacitance measurements, and basic troubleshooting. Keep practicing and always prioritize safety.